Welcome to Super Easy Physics and Mathematics. Welcome to the review of Cambridge IGCSE Physics papers with Matthew Oishaje.
The duration of this paper is 1 hour 50 minutes. You are expected to answer all the questions. So, what is the rule? Prepare adequately. You must be able to answer every question that is given to you. And you are going to be given 12 or 11 questions. So let's see. In today, the essence of reviewing this past question with you is just to help you understand some basic way to answer the IGCSE question so that you can come out with A+. I just want you to do well in physics. Physics is the easiest subject on earth. So don't have to be afraid of physics. It's very easy. So all you need to do is just do some preparation and know your formula, then know the concept, the principle behind each concept. And then as you review this paper with me, I'm going to be sharing how those little physical concepts can be interpreted. So let's go. As we look at this question, it's going to be fun, so let's just go through it. So can we jump in? Are you ready? Question 1. A battery provides an energy to an electric car. So we are looking at energy, the flow of energy. The electric car has acceleration of 2.9 meters per second square when it moves from rest. So the initial speed is 0 from rest. Take note, U equals to 0. The combined mass of the car and its driver is 1,600 kg. Calculate the time taken for the speed to reach 28 meters per second. So this is one of the first equation of motion. So this equation we are going to use, the final velocity is equal to initial speed plus the acceleration multiplied by the time. Or if you put it, A is equal to U V minus U all over T. So let's substitute here. What is our U? Start from rest, that is 0. What is the final speed? 28, that is V. What is the acceleration? A, 2.9 multiplied by time. So all you have to do to just get your time, you divide both sides by 2.9, that will give you your T. So the time taken for the car to accelerate from 0 to this speed is 9.655 seconds. So approximately 9.7 seconds. So that is the time taken. Calculate the force required to produce this acceleration. Don't get confused here. Force is equal to mass times acceleration. So it's as simple as that. Alright, I told you. So what is the mass of the car and the driver? 1,800. What's the acceleration of the car? Is given to you. Substitute. So that will give you 46,400 Newton. So that is the force. Now calculate the kinetic energy of the car when its speed is 28 meters per second. Now what is the formula for kinetic energy? Kinetic energy is equal to half mv squared over 2. So in other words, you put it mass times the square of the velocity divided by 2. So that will give me the mass of the car and the driver 1,600 times the velocity of the car. That will give you 28 meters squared divided by 2. That will give me 2,627,200 joule. So that will give you that. Okay, it's as easy as that. Now the time taken for the car battery to be recharged from 0 charge to full charge is 8.3 hours. The charge is delivered to the battery by a charger with a current of 32 ampere. Calculate the charge supplied by the charger. So in other words, so what we are trying to look at here, we are going to calculate the quantity of charge. So Q is equal to current times time. So as easy as that. Okay. The more the time, the higher the charge transfer to the battery. So, and it's a function of the current flowing. So if you look at that, so supply, but take note, there is a trap in this question. 8.3 hour. Don't put that 8.3 hour in the place of the time. You must convert it to second, which is the standard time of unit. So you must take note of that. So if you do that, that is going to give you, so convert 8.3 hour to second. 60 minutes make 1 hour. 60 seconds make 1 minute. So if I convert 8 hour to minute, it will become 8 point this times 60, convert it to second times 60 again. So that give me, so which about 956,160 coulomb. So that is the charge delivered to the battery. Now, under ideal condition, the car can travel a maximum distance of 390 km when the battery is fully charged. Suggest why in normal use, the car needs to be recharged after traveling less than 690 km. There are a lot of reasons. There is no way the car will travel directly. As you are moving the car, you might get to a point whereby the car have repeated acceleration and deceleration, so it's not going to move with a straight speed as the clone flies from to the destination from where it started moving. So the car make repeated acceleration and deceleration during the journey, and so for each acceleration the energy needed, and then there's also air resistance. The car repeatedly make use of brake during the journey, and so it move with varying speed. The car move uphill and on even road surface. So there are a lot of reasons why the car. So these are just some of the few reasons. The car uses more energy to overcome overhead wind, that is air resistance, and greater air resistance. So you can see why, if they give you those output, this is the ideal condition, but in real life the ideal condition does not is not applicable, because there are real life factors. So let's go to question 2. Water is held behind a dam in hydroelectric power scheme. State the main form of energy stored in the water behind the dam. Gravitational potential energy. The water is released from the dam and it falls to a vertical height of 410 meters at the rate of 480 kilogram per second. Calculate the rate at which energy is transferred by the falling water. So you are looking at the rate at which energy, so the rate of energy transfer. Now what you need to know is, what they are looking for here is, they are telling you calculate the power of the dam. So what is power? Power is gravitational potential energy, mgh, divided by T. Okay, so if you look at this, the power is mgh, gravitational potential energy. So mgh, the mass per unit time, that is this now, m/t. Okay, so per second multiplied by the strength of gravity multiplied by the height through which the water fall through, 410, divided by that, so that will give me 1,968,000 joule per second. So that is the power, or watts, the dam. So the power scheme supply a current of 270 ampere at a voltage of 6,000 volts. That is 6 kilo kV. Okay. Kilovolt. Calculate the efficiency of the power scheme. So you have the output and then you have the input. So now power output over power input expressed in percentage is the efficiency of the power scheme. So we have the power output is the power supply, while the power input is the power that the hydro converted to kinetic energy that we have here, the power that we just calculated in previous question, which is the input power. Then the output power is the power that the hydro dam is releasing. So once you know, we are given the current, we are given the voltage, so you can multiply that. So 6,000 volts multiplied by 270 ampere divided by this power here, so that will give me about 82.3%. so that is the efficiency of the, so that is the power scheme is highly efficient. So that means the power that is lost in the process of the conversion is just something less than so take away this from 100, so it's highly efficient. Okay, the hydroelectric energy is a renewable form of energy. State one advantage of hydro power scheme. It causes, state one disadvantage, of hydro power scheme. It causes damage to habitats. For example, fish, it destroys the habitat of fish, because it obstructs their free movement because of the damming of the river. Its construction is expensive. Hydroelectricity can not be generated in drought when there is no high volume of water, and then it has a flood risk if the dam bursts. Very good. All right. Okay, because it can lead to the flooding of the downstream plain or land. Okay, the downstream, the delta area of the river that is dammed, so it can cause flooding. That was now state one other renewable source of energy. Well, this is a giveaway question because you have up to about 9 forms of energy you can mention. So we have, let me give you 6 of them. Renewable energy, you have biofuel, you have wind, you have geothermal, you have tidal wave, you have solar panels, you have wave. So you have all those ones. So right, question 3. Show a boat stored in a shed. The boat is suspended from the ceiling of the shed with 2 ropes. So this is the boat, and then you have 2 tension rope holding the boat to the roof, and then the ceiling, the rope is inclined at angle 60 degree to the horizontal. Okay, the tension T in each of the rope is 75 Newton. 75 Newton. Okay, so what do they want us to do? Draw a vector diagram to determine the resultant of the force exerted by the 2 ropes on the boat. Calculate, state the scale you use. So what you are going to do, so we are going to so in this one, let's use the scale of 2 cm to 25 Newton. So if you have 75 Newton, so we need to find out the boat. So you know, inclined to the, so 75 Newton will give me 6 cm. Okay, so how many? 25 is in 75, 3. So 3 times 2, that's how I have 6 cm. So that means each line that will represent the tension. So I have this, you have the vertical 60 degree to the horizontal. Okay, then you draw your 6 cm, 75. So then at that point, draw the other one, horizontal So you have another one again, 60 degree. Okay, the second tension, 60 degree. All right, so this is the second, the one adding to the right, then this one adding to the left. So if you do that, then what is the resultant? Is a line that move from the beginning to the end through the vertical. So you get that. Okay, so 75 Newton. So this is the resultant force. So let's see how long is that. So if you look at it, it's giving us about so 10.3 cm. Then remember your unit, 2 cm represent 25 units. So let's calculate the resultant force, that is the purple. So divide that. So if you do that, that will give you 128.75 Newton. So that is approximately 130 Newton. So the direction, you see that is acting vertically. So 90 degree or 0 degree or vertically. So that is the direction. Now determine the mass of the boat. What is the mass? We were given mass of the boat is the weight of the boat divided by strength of gravity, and you were given, so 130 resultant divided by 10, that will give me about 13 kg. Okay, now force is a vector. Draw a circle around two other quantities in the list which are vector. This is a giveaway question. You have a vector quantity has magnitude and direction. So you have acceleration, you have momentum. So these are them. So example of vectors are velocity, displacement. So question 4. Yes, this is Brownian motion. So if you look at this, the glass has a light, then the smoke as seen as bright speck of light when moving through the microscope. Okay, so you have smoke particle, so you have air particle, very small, you can't see it, but when you release smoke into it, so the smoke, so draw the path of one of the bright speck. It's just a zigzag motion, just scribble anything. Okay, so you have that, just a zigzag motion, so it comes zigzag anyhow. So we'll give you, just scribble anything here that will give you the direction, because the smoke, the air particle does not have, is a random motion. Random means anyhow, so just scribble. All right, let's go to explain in terms of force and the motion of air particle, the cause of the motion of the smoke particle. Now, air molecule bombard smoke particle. You cannot see the air, but the smoke you can see them. So as the air is bombarding the smoke, so it produces motion. So air molecule are small compared to smoke particle. Then air molecule are very fast moving. So air molecule move in random motion. The collision exert on equal balance force on smoke particle. So you look at that. So any of these things here will stop. Now the temperature of the air in a sealed glass container is increased. So look at kinetic theory. Explain in terms of molecule why the internal energy of the air increases. Explain in terms of molecule why the internal energy of the air increases. So if you look at that, okay, explain in terms of molecule why the internal energy of the air increases. So when you have that, kinetic energy and potential energy of the molecule increases, hence the internal energy increases. Okay, so that's as easy as that. Okay, explain in terms of molecule why the pressure of the air also increases. So bigger change in momentum of the molecule, or the molecule hit the wall harder, okay, when the temperature increases. Then the molecule hit the wall more frequently, okay, because they move faster. They move from the end of the container to the end of the container within a shorter time, so they hit the wall more frequently because the speed has increased, okay. Then question 5 had to do with heat capacity, thermal physics, okay. Define specific heat capacity. Simple. This is the energy required to raise the temperature of 1 kg of a substance by 1 degree Celsius. It's as easy as that. If you are talking about a unit mass, okay, 1 kg, if it's 1 kg of water, what is the amount of energy needed to raise the temperature of water, assuming it was 10 degree to 11 degrees Celsius, just by 1 degree Celsius? What is the amount of energy? For water, it is what? 420 joules that you need. So that is the heat capacity of water. Now, question B. A bowl contains 500 cm cube of water at the temperature of 5 degrees Celsius. The bowl of water is placed in a freezer for several hours. When the bowl is removed from the freezer, it contains ice at a temperature of negative 18 degrees Celsius. The density of water is 100 grams per meter cube. Calculate the mass of water in the bowl when it is placed in the freezer. Okay. Now, density is equal to, so density is equal to mass over volume. So you make mass, so the formula is density times volume. So 1 gram multiplied by this will give you 500 grams. Okay. Then remember, so I want to convert that into kg. That will give me 0.5 kg. Okay. The specific capacity of water is 420 joule per kilogram per degree Celsius. The specific capacity of ice is 2100 joule per kilogram per Kelvin. The specific latent heat of fusion of water is latent heat of fusion, that is the melting, okay, per kilogram. So the energy needed to melt 1 kilogram of water is 3.3 times 10 raised to the power 5 joules per kilogram. Calculate the energy given out as the water cool from 5 degree to negative 18. Wow, this is change of state. So first of all, is the energy release is going to be heat release to cool the temperature from 5 degrees Celsius to 0. Then you now calculate the heat release to melt, to freeze the water at 0, and then the heat release to cool the water from 0 to negative. So here you have the heat capacity of water, latent heat of fusion, then you have the specific capacity of ice. So it's a 3-stage question. This is actually a little complex question. Cambridge highly set this type of question, but we started moving there. Alright, so let's see. So the mass of water, so the mass of water, which we've already calculated, 0.5 kg. Specific capacity of water multiplied by temperature change, which is 5. Then latent heat of ice, latent heat of fusion, the mass of ice. So because the same amount of water will turn to ice, so the same 5. Then the mass of ice that will be cooled down. Then specific capacity of ice times temperature change in the solid state, which is from 0 to negative 18. So here will give me 18. So substitute our value. So we have 0.5 times 4,200 times 5 plus 0.5 times 330,000 plus 0.5 times 2,100 times 18. You know why we have 0.5, 0.5 is because it's the same quantity of water that got frozen and the same quantity of water that converted from liquid to solid got frozen, and then the temperature started dropping after it solidified. So the same quantity, so that's why 0.5 remain constant in this calculation. So get that will give me total 194,400 joule. So that is the quantity of heat needed. So with that, you put your 9 points in your pocket. Very good. Go through it again. You will understand it. Alright. Now let's go to wave. Yes. In this case, I think we are looking at diffraction. Now draw 3 crests of the water wave to the right of the barrier. So the first thing you need to know, you have to compare the wavelength of the incoming wave with the gap. So if you look at it, what is the condition? The gap is smaller than the wavelength. So diffraction happens. But if the gap is bigger than the wavelength, there will be no diffraction. So since there is diffraction, they will spread across. So we have that. So the wave is going to spread to the other side. But mind you, when after diffraction, the wavelength remains the same. So if here is whatever is the wavelength here must be the same wavelength here, the spacing. Okay. Now in this case, we are looking at refraction of water, deep water to shallow water. Okay, the water moves slowly in the shallow water. So they've even given you the answer. The water moves slowly in the shallow water. That means it is refracted, or is going to bend. The direction will change towards the normal. So first of all, so wave slow down in shallow water. So take note, it's already given to you here in the question. Draw 3 crests of the wave. So let's look at this. So this is the direction of the incident wave coming. So at this point, you draw your normal. Okay, and once it enter, so this is the deep water, then this side is the shallow water. So take note. So the wavelength will be shorter. So this is so what happened? He bent towards the normal. So this is the normal. The normal is this dash. The broken line is perpendicular to the surface, it's 90 degrees. So he bent towards the normal. So, and because he is lower, the speed of the water wave becomes slower in shallow water. The wave front will be closer. So look at it. So the wavelength is shorter. Here the wavelength is longer. So that is just some 3 basic things you must know. 1, this wavefront, you must draw it, and it must be perpendicular to the direction of the refracted wave. Alright, so let's go. State 2 ways in which transverse wave differ from longitudinal wave. So let's put it in a tabular form. Transverse wave, longitudinal wave. Transverse wave. The wave in transverse wave vibrate perpendicular to the direction of travel of the wave, propagation. While in longitudinal wave, the wave vibrates parallel to the direction of wave propagation. So then here we have trough and crest, but the way from here you have compression and rarefactions. Okay. Your 2 points. State a typical value for the speed of sound in water, or a range from 1000 to the value less or equal to what? 2000 meters per second. So anything you want to put 1200, 1500, 1700, 1000, whatever. So within this range you are correct. Just write something. Okay. Now explain why sound travel faster in water than in air. So it's just the particle arrangement. Molecule of water are closer than molecule of air. It's as easy as that. So water has greater density than air because the speed is proportional to the density. Alright, question number 7. Show a plane view of a room. Then you have a mirror on the longer side of the room, and then you have somebody, the plane view. There is a mirror on one of the wall with a picture across AB, and a person is standing at position X here, okay, and is looking at the mirror. The person cannot see all the pictures on the wall AB reflected. So there is a point P on the wall AB, which is the closest point to A that the person can see reflected mirror. So draw a reflection ray to do this. So they just want to test your understanding of the principle of reflection. So if you do this at the edge of the mirror, you draw your normal. So you use the principle reflection to take place. The angle of incident must be equal to the angle of reflection. So if I use this one, so this one I'm using 62, angle of incidence 62, angle of reflection too will also be what? 62. So then the person here can see. So remove the protractor. So I'm just using the protractor to do that. I hope you understand. So the person, that is a point P, so I remove that. Let's see all those ones. So if you look at that, and visible light is an electromagnetic wave. State the name of two regions of the electromagnetic wave in which the wavelength, shorter wavelength than visible light, and then longer wavelength than what? Visible light. Okay, so let's go to the next page so that we can have enough space to answer this question. There's something I need to explain before we answer it. So let's go. Okay, so haven't seen that, so connected in parallel to that. Okay, all right, let's see. What do we have here now? The potential across that, we've done that. So let's next question. The electromotive force of the battery is 12 volts. The component will have a resistance of 400 ohm. In a brightly lit room, the resistance of the component is 350 ohm. Calculate the current in the circuit. So the combined resistance will be 750. Use it to divide the 12 volts, so that will give me 0.016 ampere. Calculate the PD across the Y. PD across Y is equal to the current times the resistance of Y. So that will give me 6.4 volts. In a dark room, the resistance of R is very large. State the effect of this will have on the PD across Y. The PD across Y decreases in a dark room. Okay. Why? Current that will flow will become very, very small because of the high resistance of the light dependent diode. Okay. Suggest a practical use of X. Switch on light at night. Okay. Turn on security lights at night. So you have that. I think with that, if you understand it, you have your 7 mark in your pocket. Yes, your grade is increasing. So let's go to the next question, number 9. Question number 9 had to do with magnetism. So you have a spring, you have a galvanometer, okay, you have the iron coil, and then the spring is oscillating in the solenoid of the galvanometer. Okay, now show a magnet on the end of a spring and a coil of wire connected to a sensitive zero galvanometer. The deflection can move freely through the coil. So the magnet can move freely through the coil. So you have that magnet. Now the magnet is pulled up and released. So what happened? Describe and explain what happened to the needle of the galvanometer. The needle oscillates as magnet move up and down. The coil cuts magnetic field, and the magnetic field changes as magnet move. The changing magnetic field induces voltage or current in the circuit of the coil. The induced voltage opposes the motion causing it. So what is going to happen is slow down the magnet, the spring. Okay, so the force or the magnetic field and the induced current are mutually perpendicular. Okay, so with that you have your 4 mark. Then the magnet is placed in a stronger magnetic field. The magnet is placed in a stronger magnetic field. State the effect of using the strong magnet on what happened to the needle of the galvanometer. So if you put it, so it produces a larger deflection. Okay. A stronger magnetic field means stronger current that will flow through, that will be induced in the coil. Now, a step-up transformer is used to step up the input voltage of a power station from 25,000 volts to 40,000 volts for transmission along power line. The number of turns on the secondary coil is 36,000. Calculate the number of turns on the primary coil. Simple proportion. So primary voltage over secondary voltage is equal to primary turn over secondary turn. So substitute your value. So you have that, and then I give you 2,250 tons. So as easy as that. So you have your 7 mark in your brain. So let's go to question number 10. A student placed a sample of an isotope of protactinium Pa234 near a radiation detector. The reading on the detector taken every 20 seconds are recorded in the table. So when it was 0, what was the count rate? 101. 20 become 88. 40 76. 60 66. 100 that. Now show a graph of the count rate due to this sample against. So we have this 88. Explain why the reading in the table is not the same as those plotted on the graph. You have background radiation present in the table, so the background radiation has been eliminated. Background radiation has been removed from before plotting the. So the background radiation removed, and then with that, so using the graph, determine the half-life of this isotope. So if you have that, the half-life, half of 80 is 40, that will give you 72 seconds. Sorry. Okay, so let's look at this. I want to explain how you balance the equation. So if you look at this, what happened here? 2, 3, 4. Let's look at the atomic number 91. So the right hand side have to be what? You know why uranium become 92? Because of this negative. So if 92 take away 1 will give me balance with 91. So then the mass number or the nucleon number 234 on the left hand side, 0 plus 234, so it's balanced. So with that, you have your 7 mark. Okay, so with that, we come to the end of physics paper 4, variant 3, May, June 2022. I know you have learned something out of this. So just keep learning. Practice make perfect. The moment you keep on practicing, you learn more, and then you upgrade your results. Thank you for learning.
As he helps you with his wealth of experience of preparing students to achieve an A+ in physics.